Welcome to the Arithmetic Zone and welcome back to another video in our Simple Java series. Today we're going to be learning how to create our own classes. So this is a pretty big part in learning Java. As I said before, Java is a class-based coding language where much of the code is being run through making a bunch of custom objects where you're able to set many different methods and properties for each object. So we already looked at the string class, which is a default class in Java where we can reference its many different methods and set its values to basically any character on the keyboard. Now we're going to make our own class, but before we do that, I think we need to go over what really counts as a class. I mean, when you think of the word class, what do you think of? Do you think of a rank? Do you think of a classroom? Well, in the context of Java and in other coding languages, when you say a class, basically just means a blueprint of a specific object. So let's say you were trying to make an apartment, right? But you want to make multiple apartments, and each of the apartments, they're all similar. They all have maybe the same structures, same layout, but they differ a bit, say, in maybe the number of windows, number of doors, number of bathrooms, stuff like that. But what they all have in common is that they're all apartments of the same structure. So in that case, the apartment would be the class, while the various different apartments of, variable rooms and variable doors, those would be objects of the apartment class. So if you don't understand what I mean, let's get into it. You may notice that I removed my starter.java file and replaced it with a runner.java file. We're going to use this file to run our code. So this is essentially going to be where our main method is. And as for any file in Java, you're going to have to make a class for it. And we're actually going to give it the modifier public. And you're going to see why later. So we're going to call it public class and then the file name runner. And then inside of here, we're going to have our main method, which is public static void main string arg brackets args. And we're not going to do anything with it just yet. We're just going to have that right there. Anyway, we're going to make another file. And this one's going to be our apartment class. So we're going to call it apartment.java. And it's already giving me the autofill, so public class apartment. Alright, so yeah, any file in Java, you have to start with, class apartment, and you can give it a modifier public, private, and things like that. And what the public modifier does is that it allows this class, the data in this class, to be accessible by other classes. So apartment can access data from here, and on the other hand, this file can also access data from here. Now, it doesn't really matter for apartment to access data from this file because this is where we're going to run our main method, and the main method is going to get its information from the apartment class. So we have our apartment class, but we have to think about, what are all the different properties of an apartment? Like how many rooms does it have? How many doors does it have? How many windows? Maybe the cost of it. These are what we're going to call our instance variables. So these are going to be all of our different properties. And in order to define them in a class, you want to make them all private. You don't have to make them private, but it's advised to make them private. So you say private, then you say the data type of the property. So let's say I'm thinking of size. I'm going to make size, small, medium, large. We can describe that with a string. So private string size and then semicolon. Now what about number of doors? So that'd be private. Then it's a number, so we want to use int and then doors. And what about cost? Well, private double cost, because cost, can be a decimal value. So we have our instance variables, and these are properties that can describe an apartment. We can So it might be a little confusing right now, but I promise it'll all make sense. We're using private because if I make this public, then that means that I can accidentally refer to these variables anywhere in this code right here, and we don't want to do that, because when you increase the scale of your program, have a lot of instance variables, you're going to be accidentally referring to variables that you don't mean to. So it's best to just make them private, and even if they are private, there's other ways to access these values. After making your instance variables, you want to make your constructor. So a constructor is a pseudo method, not technically a method, but it's like a pseudo method that when you call a constructor, it makes the new object of that class. And for constructors, we want to use public because we want other classes to be able to, make a new object of this class. We want the runner class to be able to make a new object of apartment, so we want to make this public. So, and to make a constructor, you just say public and then the class name apartment and then parentheses. Inside the parentheses, you can put in parameters. We're not going to do that right now. For now, we're just going to initialize all these values. So yeah, usually a constructor initializes these instance variables. Now there's no parameter here, so we're just going to set some default values. So let's just say size equals small. Let's say doors equals 1 and cost equals, let's say 300.65. Obviously very, very cheap and not realistic at all, especially in the modern day, but it'll do for now. So that's our default apartment. So what I can do right now is I can go back here and make an object. So how do I make an object? I reference the class, so apartment, then I give it a variable name to refer to this new object. Let's say A1. Then you say equals new and then class name. And if this looks familiar, this is the long way to make a new string object. But because a string's a default class, we're able to use the shorthand. But for our custom class, we have to do the long way like this. We have to allocate memory space to make this new apartment object. So yeah, if we run this code, it won't do anything because obviously, it's not going to print out anything. But this line is just going to make a new apartment object and set all of these values to what I specified right here. So if we want to see this in action, what we can do is make a method, and we're going to make a void method. So a void method is a method that does not return a value. Usually you use a void method if you want to change a value, or if you want to print out something, but you can also make printing out methods non-void methods. But anyway, in this case, I just want to print it out. So we're just going to say public void print. All right. You have to specify that it's void, and then print is just our method name. And then once again, inside parentheses is parameters, but we don't need any parameters. So when this method is run, what we want to do is have we want to print out information about our apartment. So let's print out apartment, or let's say, I'm going to make this capitalized. So size apartment with that number of doors that costs that amount in dollars. So we have our print method. So if we run this code for our default apartment object, it should print out small apartment with one door that costs $300.65. But we got to call the method in our runner class. And to do that, you reference the object name and then the method. So print, just like with strings. Now let's run our code. And look at that, small apartment with one door that costs $300.65. So we know that this works really, really well. Let's look at some other methods we can make. So a common void method is updating values, and these are called mutator methods. So public void, and then we got to give it a name. So let's say add cost, and let's also add in parameters here. So we want to add the cost by a certain amount, and we can specify that with a parameter. So let's say int amount, and then to update the cost, all you have to do is just take the cost instance variable and add it by amount. And this should probably be a double. Alright, so we now have an add a cost method. So before we print it out, let's say a1.addCost, and then we have to include a parameter for this method because we never defined a method without a parameter. We're going to do that later. So let's say I want to increase the cost by 100.5. Now if we print it out, it's going to say small apartment with one door that costs $401.15 because we made an apartment with the initial cost of $300.65, and then we added $100.50 to it. So now when we print it out, it's going to print out this cost instead. Now let's make an add cost method without a parameter. So public void add cost, and then no parameter. And then this time, let's just say cost plus plus. So this is just going to increase by 1. So if I get rid of this right here, I no longer have that error because I now defined the method. And now we just have the cost increasing by just a single dollar because we used plus plus. This is called overloading methods, when you have basically the same method but they differ in parameters, and they can differ in multiple ways. They can differ by the number of parameters, so I have 1 versus 0. They can differ by the order of parameters. So let's say I have, I don't know, int x, doesn't really mean anything. I could have here double amount and int x, and this would still work as long as you put an integer here and a double here. Java knows which one you're referring to. Or if you put a double first and then an integer, Java knows you're referring to this one. So it differs by order, differs by the number, and also just differs based on the type of parameter. So let me just put it back. So I could also just have string here, and that would also work. What you can't do is have the exact same parameter. You see, it gives me that error. You can't have these two same methods because now Java has no way of telling between them. And also worth mentioning, the return type, even if you change the return type, you still can't do it. Even if you return a value, still can't do it even if you change the return type. So keep that in mind. But you might be confused on what I just did right there. I essentially just wrote a non-void method. So let's get into that right now. Unlike void methods, non-void methods return a value upon calling them. So what does that mean? Well, let's say I have a non-void method, right? Let's say this is a non-void method. What I can do with this is I can print this out, and it's going to print out a value that it returns. Or I could set this equal to a variable, and then I could reference that value through the variable later. So let's make a non-void method right now. And to make a non-void method, you have to specify what type of value you're returning. Are you returning an integer, a double, a string? You got to specify that. So we're gonna make a non-void method that returns the cost. So we want it to return a double value. So public double. We're gonna call it get cost. So this is essentially an accessor method where we're able to access the data of the instance variables without having to use the actual instance variable itself. Instead, I get to control what data is accessible from other classes using this method right here. So if you're wondering why I have this red underline error right here, it's because I'm not actually returning a value right now. It's just a blank method, and Visual Studio Code is always going to give you this error. If you make a non-void method and don't have any value you're returning, you have to return the value that you specified right here. So I have to return a double. So we want to get the cost. So all we do is just say return cost. So now if I want to access the cost directly, so I just commented out my previous methods, so now I just have my get cost method. So let's print it out, and nothing seems to happen. Well, remember, this is a non-void method, and unlike the print method, which actually has this print statement right here, the non-void method is returning a value. So when you use a non-void method, you have to do something with this. So I have two options. My first option is I can just print it out directly, because essentially this a1.getCost, this basically equals a double. So I can print it out directly, 300.65, or what I could do is put it in a variable. So let's say double cost equals a1.getCost, and this cost is different from this instance variable cost, just so you know. And then I can print out this new variable. And the same thing happens. Now I want to go back and modify my print method so that it's now a non-void method. So how can we accomplish this? We're going to do this by making a toString method. So let's replace the void with string. And then instead of having the word print, we're going to say toString. And make sure it says toString. Now we're going to replace this print statement with return. And now we're going to, our print method's already commented out, so it's not going to do anything. Now what we can do is have a print statement in our runner code, more appropriate, and say a1.toString, and it should function the same because it's returning a compound string with all of our instance variable information with it. You might be wondering, this seems like a lot of work. Well, the cool thing about toString, and specifically toString, is that you don't actually need to specify the method name toString if you want to print it out. You could just say a1 and it will still print. And we're going to go over why that happens specifically with the toString method in a future video. But for now, just know that you have to make your toString method spelled like this. You have to make it return a string. And if you do that, you can just print out an object directly without having to reference the toString name. Now I want to go back to our constructor because, it works just fine, but what if I want a different apartment? After all, that's the whole point of the class, so we can have different objects that follow a similar blueprint. So what we can do is overload our constructor just like how we overloaded the method. So we make basically the same header, so public apartment, but we differ it by the parameters. So this is our default constructor, where it just gives us these values if you don't input any parameters. Now let's write in some actual parameters. So let's say string s for size, int d for doors, and double c for cost. And inside here we're going to initialize size into whatever value s is, initialize doors to whatever value d is, and cost into whatever value c is. So now we have a constructor where with 3 parameters, where depending on what the user puts in the runner code, it's going to make an apartment with those values. So let's make a new apartment. So let's call it apartment A2 equals new apartment. And now we want to specify the second constructor with all the different parameters. So the first one is an integer, I believe. Let me just double check. Okay, no, it's size. So First one is size, so let's say large. Then the next one is integer, which is the number of doors. Let's say 3. And then the cost, so let's say 2000.50. So those are our parameters. And now let's print out that new apartment in the format that we specified with the toString method. So print out everything, and we now see in the second line, large apartment with 3 doors that costs $2,000.50. The 0 doesn't show up, unfortunately, because doubles are just like that. But luckily we know that this works. So we made a separate constructor that's more customizable using parameters. And what's cool is that you can make as many constructors and as many duplicate methods as you want, as long as they differ by the parameter. But obviously it's going to get tedious when you just have similar code. So how can we make this more simple? We can use a special keyword called this. And what this refers to, this just refers to the current object. And the cool thing about this is that you can call constructors and you can call methods using the this keyword. So what's quite common to see is that the default constructor is going to end up using the this keyword, and it's going to call the constructor with the most amount of parameters like this. And then what we put inside these parentheses are our default values that we wanted. So we wanted small, then 1 door, and then I believe it was like 300.65. So when we use this, we're referring to the current object, and then when we set it up this way, we're essentially calling this constructor, and we're putting in these values, and these are the same values that we had before. So now if we run our code, it's going to function the exact same, because when I make a1 and call the default constructor, this constructor is going to call this one by putting in these default values into here. And then a2 is just going to directly call this constructor with the values I specified here. So that's pretty cool. Another cool thing about the this keyword is that this can help differentiate between parameters and instance variables. So let's say I made this size, and I made this doors, and I made this cost. That would obviously present a problem because I'm trying to set, these parameters into these instance variables that are named the exact same, and then Java gets confused as to what is what. For the record, if this does happen, Java just assumes that these names refer to the parameters and not the instance variables, because these have priority. But to prevent that, you can use the this keyword. So this dot size would refer to this object's size instance variable, not the parameter. This dot door is same thing, and this dot cost. Do it this way, our code works as intended. Of course, you can just avoid this issue altogether if you did what I did and just make your parameters single letters or other variations that differentiate from the names of the instance variables. But if they do happen to match, just know that you can use the this keyword to help pull you out. Another thing to note about the this keyword is if you ever call a constructor with it like this, make sure it's the first line in the constructor. So I can put in whatever I want in this constructor. Like I can have the number of doors change after it, and it's gonna work. But I cannot have this line before the this keyword. That's gonna present a problem. You have to have this come first. So just keep that in mind. The final thing I'll be covering in this video are going to be static methods, which are special methods that are essentially used to keep track of data values that all objects of the same class share at the same time. So that might sound a little confusing, but the way I set this apartment class up, you may notice that, the size, the doors, the cost, these are all exclusive to their own apartment object. They all share these same properties, but the value of these properties are different depending on how each object of the class is made. So what that means is I can't just have a variable that they all share and that they all share the same value when I update it, unless of course I use a static variable. So we're going to do that right now. What static variables are useful for are keeping track of like the total number of something. So we're going to make a static variable, a static instance variable. We're going to call it private static. We need this modifier, then int, and then we're going to call it count. And every time we make a new apartment object, we're going to increase the count by 1. And I can just have that right here, and I don't even need to include it here because this constructor is always going to call this constructor in the end. So I can just have my count variable here. So every time you make a new apartment object, this variable is going to go up. And this variable is going to be shared between all of the different apartment objects that you make. It's not going to have like its own value. So we're going to make a new method to access this new static variable. We're going to call it public int get count. And it's going to say return count. And technically you want to make it static. It's just more proper that way because now this method is shared between every instance of the apartment class. So what that means is when you have a static method, you don't actually have to reference the object name. You could if you want to, but you can just reference the class name directly. So after making these two apartment objects, what I can do is say system.out.print line and then apartment.getCount. And it makes sense to refer to the class name and not the object name because it's going to be the same no matter what object I do. And it's going to return the count of 2 because I made two apartment objects with the count increasing each time I made one. And if this looks familiar, that's because we've been working with static methods before with the math class, which is like another default class, and basically all of its methods are static. You reference the class name math. You don't have to make an object of math class because you're just trying to access a bunch of methods that aren't unique between each object. So that's the cool thing about static methods, and that's the cool thing about just making classes in Java in general, because you're able to make these as crazy as you want, as customizable as you want, and the limits are basically endless. Like there's really nothing preventing you from just having a ton of methods, unless everything is named the same. You don't want to do that no matter what. So this is just a basic overview in making your own classes, and this concept will definitely be featured in future videos where we're going to cover more data types of Java, specifically arrays and array lists. So I'll see you guys next time.